Scott Sivjan from University of Massachusetts Amherst. He's going to talk about joint performance in the Northeast states. And what Scott doesn't know is I spent my last 2 years at Fort Devens in Massachusetts. Loved it. So.
Well, thank you. I'm very glad to be here, and thank you for inviting me. I brought a laser pointer, and I need to pick a screen. So I'm probably going to go this way so that you're not seeing the laser dancing off of Chris's forehead. I'm going to talk about bridge joints in the Northeast states, which I hope you'll find that there's a lot of similarities. There's some differences. Brooke Quinn was the graduate student that worked on this that put together most of this. And this was a project that was done for Mass DOT. The project started out with a literature review, and then we looked at the database of Mass DOT bridges and their joints. And what is a little bit unique about this is we met with each of the 6 Mass DOT districts and had 2 to 3 hour meetings with personnel from the bridge engineer, the maintenance group, the inspection group, to have a fairly robust conversation of what was going on with their joints. And then we created and distributed a survey to 9 Northeast states based on those discussions and compiled the survey responses. And that's what I'll be talking about today. The full report is available from Mass DOT. There was also, as was mentioned, the TRB paper that came out of that. And in the TRB presentation and this, I'll be focusing on just an overview of the joints, the Mass DOT district information, and some of the survey results, the overall findings, details of Mass DOT practice, and some of the more detailed survey responses are in that overall report. So why do we worry about bridge joints? I think everybody in this room knows that if you don't worry about bridge joints, they're going to leak and you're going to get a lot of damage, a lot of corrosion to the superstructure, a lot of corrosion that starts happening in the substructure. And this in the Northeast is not an anomaly. This is a bridge I've driven under that's looked basically like this for the last 10 years, and it is typical of the bridges up and down the interstate system in Western Mass. The rate of corrosion, one thing to keep in mind is that once they start looking like this, it's not a linear relationship. So I've done some corrosion studies as well, and once it starts corroding, you start getting the spalling, and it just progressively increases and increases almost exponentially. 2 surveys that were already out there that we used as a basis to start out. There was one by Purvis in 2003, which was an NCHRP synthesis report. And in that, they did a survey to 34 states and 10 Canadian provinces and included 7 of the states in this study. And one of the things that they found was that the strip seals they found were fairly successful based on the responses. And importantly, construction quality and maintenance were significant factors, and I think to everybody in this room, that's not a surprise. Another survey that's much more recent in 2014 focused on small movement expansion joints, so 2 inches or less, in the Northeast. And this included 12 states, 9 of the states, including all 9 states that we sent out surveys to. And in this, they also found the strip seal being common for new construction and repairs. Asphalt plug joints and pourable seals also common for the repair. They noted poor quality in the responses for compression seals. And once again, the construction quality and maintenance were significant factors in how the joints performed. So now I'm going to go through just very quickly, which may be redundant to a lot of your backgrounds, but just a couple of the joint types to make sure that we're talking about the same types. These are the ones that were predominant in the region. So saw and seal for very small movements, less than ½ inch. You saw cut, you fill it with the sealer. Asphalt plug joints for up to 2 inches, some went to 2.5 or 3 inches, but you have the joint with the backing rod, you put in the plate and the asphalt binder. When these fail, the typical failure is rutting or cracking in the asphalt, so a lot of pictures of this where it's just pushing the binder out of the joint and the cracking. Compression seals that were pretty predominant in the past, and the question is whether to replace them or replace them with something different. The typical failure that people were seeing is the joint is there and the debris starts building up. This is after the joint has failed and looking underneath the joint where this is the compression seal that has fallen out with all of the debris. And it's just that as the traffic goes over this, the debris builds up. If it's not cleaned out, it keeps pushing it down a little bit more and a little bit more until eventually it can push out the entire joint or portions of the joint. Strip seals were a way of fixing a lot of those problems where you have the steel extrusion with the header and the seal gets fit into that and goes along. But with time, there are problems with these as well. And here's a failed one. And what happens is the debris also fills up if it's not cleaned out. The debris will eventually abrade or puncture the seal, and that is a fairly common failure of this type of joint in our region. M-Seal I bring up just because, well, not just because. It was mentioned by several of the DOTs as a newer product that they were using that there was significant information on, and you'll be hearing about this and the other ones that I'm mentioning later. It has some foam with the silicone topping and is adhered to the sides of the joint. And what was pointed out on this that they liked at Mass DOT in particular with the districts that were using it was that in the area that they had a lot of problems sealing their joints were at the parapets and curbs. And so it was almost predominantly due to the fact that this can come in preformed angles sized to the curbs and parapets that they found to be much easier to install around those locations and not have the leakage problems that they were having for some of the other types of joints. A pourable seal for up to 4 inches, and very simple. You put in the backer rod, you pour in the silicone. One issue that comes up on this is that people don't really think of that backer rod as being that important, and it's very important. So the depth of this, if you think of this poured silicone, is your bond. And so if this backer rod is too shallow, then you don't have much bond in there. And what can happen is it just pushes through similar to the compression seals. Okay, and this can be localized or along the entire length of the joint. When you get into larger movements, we move up to the modular joints for greater than 4 inches, and this becomes a complicated system. You're putting in individual seals with support bars and center beams to attach all of this to. And the problems that will often happen, not often, that can happen or lead to failure is fracture in or cracking in some of the support bars or the center beams. That often then redistributes load and becomes kind of progressive through the joint. And here is one of the failed modular joints in Massachusetts. So those were all closed joints. So closed joints meaning that we were putting the joint in there to keep moisture or water from seeping through the joint. The other type are open joints. So there is the pure open joint, which often they will do as a quick retrofit of a compression seal that's failed, is they just take it all out and they let the water go through, which is a really bad idea and leads to a lot of deterioration. And then there are designed open joints, such as a sliding plate joint for less than 3 inches, or for larger movements, the finger joint. And in these, you're letting all of the water and salts run through the joint, and the key to this then is the trough at the bottom. And so you're collecting all of the water, and the drainage system is the important part to make these work adequately. So how do these fail? Well, there are 2 things. This is with any type of joint, but here's a picture of a finger joint that if it's not installed correctly, so this was at 75 degrees Fahrenheit in Massachusetts, which is a spring or fall day, and the joint is almost entirely closed up at both ends of the bridge, so when it gets to the summer, it's going to be bearing up against the sides. This is a joint that's performing well, that's only been in service for 8 to 10 years. But when you look through it, this lighter color is the trough that has torn, and there's a lot of debris if you look into that, look down into the joint. And that's typical of the joints in this bridge, is that almost all of the troughs are torn and just allowing all of the water to go down onto the substructure. So if the joints aren't performing, the options are to go to jointless bridges. So integral abutment, semi-integral bridges are becoming very popular for a bridge of choice for smaller spans in our region. Or for a retrofit or redecking, sometimes they will be moving to these link slabs where they're essentially putting in a slab over the joint with a sealer. So those are the types of joints that were being used. And we went to the different districts. So 6 districts in Mass DOT. We went to all of the districts, had these meetings. And each district has its own characteristics. So District 6 is Boston. That's very, very urban, lots of traffic throughout the region. District 1 is out in the Berkshires, mostly rural, smaller span bridges. And then 2, 3, 4, and 5 have their own characteristics. But 2, 3, and 4 tend to have a mix of cities at least a city in the area, and then a lot of rural areas as well. And what we found, so this is just a list of the inventory of those different locations, but what I'd like to draw your attention to is District 1, as I mentioned, is rural, a lot of short span bridges, low traffic volumes, and when you look at their total bridges versus jointed bridges, it's a low percentage of their total bridges. When you look at saw and seal joints, those are generally not included in the jointed bridges, and so that is a lot of their bridges, okay, a lot of their joints. When you look at Boston, which is District 6, which has the urban bridges and the high volume, most of their bridges are jointed bridges. They are also a lot of older bridge inventory. And then 2, 3, and 4 having a mixture of those. District 5 was a little bit unusual as well as far as the districts, in that it is dominated by limited access highways with high traffic volumes. So in these discussions, we found, or what kept coming up, is that when they had the low volume and shorter spans, the lane closures were common. They would shut down the road because they needed to replace or repair a joint. Okay? If they wanted something where they needed high performance concrete that they wanted in a header, they would shut down the lane for as long as it took for that to cure, whether that's 7 days or whatever they felt was adequate. In the other areas, District 5 and 6 in particular, high volume, limited access highways, they were looking at that 8 p.m. to 5 a.m. window for work and Monday through Friday, and therefore they were only using quick setting headers, and they would acknowledge that those did not perform in their experience as well, but they needed to use them for the construction time period. They also did less surface preparation. So there were joints that required surface preparation, required sandblasting, and so forth. And they would waive those requirements to meet the construction schedule. Okay. There's also a little bit of an anomaly in Massachusetts in that the turnpike runs right through the center of the state, and it was under a different jurisdiction when it was constructed, so a completely different wearing surface that's thinner. And that thinner wearing surface, now that everything is underneath the same umbrella of Mass DOT, they found that there's quicker deterioration of the joints due to the thinner wearing surface and the traffic volumes on the turnpike. So here is, based on district, the different bridge inventory as a percent of the bridges in that district. The red is strip seal, the next is pourable seal, compression seal, modular, open joints, true open joints, and then other, which according to the DOT, was essentially their asphalt plug joints and sliding plate are what they think dominate those, mostly the asphalt plug joints. And I show this just to point out some differences in the different districts. And so the first is that District 2 and District 6. District 2 is fairly rural. District 6 is downtown Boston. And asphalt plug joints are about the same percentage. Even though District 6, it should not be used necessarily in a high volume road, but they use it because of the ease of construction and the quickness of being able to put in those joints. Another thing is that District 5 has a huge number of asphalt plug joints, even though it is also a very high volume roads. It has a lot of high volume roads because they feel that it is something that they can come in. I'm sorry, I said that backwards. District 6 has a lower number of these. District 5 has a lot because they like them due to the construction time. District 6 and District 2 do not like using them, mostly because of the district bridge engineers' perception of how they've performed in the past, that they've been trying to get rid of the asphalt plug joints. District 4 has the lowest number of strip seals because they've been phasing them out and putting in more pourable seals because they feel that those are better for the maintenance crews. In Massachusetts and in many of the other states that we were interacting with, new construction was centralized. So if you had new construction and that also included the redecking of bridges, there were central office requirements for what types of joints could be used. When it went to repairs, it was based on the district, and the district engineers generally made those decisions. And the central office would try to impose types of joints, but it was up to the districts to use what they want, and they usually, not often, overruled what the central office was recommending. For maintenance is also district specific, depending on their maintenance budgets, and they can allocate them however they want, and there was wide variation in how they maintain their joints. And there is no existing joint maintenance policy anywhere in Massachusetts at the time. There used to be, but due to budget restraints, they've gotten rid of those. So what we found was that there was a wide variety of bridge joint types that were used and preferences just within Massachusetts, and that didn't correspond with the surveys that were sent out before, because in those it was generally one person, and it just so happened to be District 3 that answered the surveys. So it only was through these individual interactions that we were finding out the subtleties of how different the practice was throughout the state. We then tried to take the bridge inventory and say, well, is there a correlation between the bridge rating, the joint rating of the condition and the traffic volume or the age of the bridge or the bridge span, and we really couldn't find any correlation between that. Okay, so we started looking into the actual discussions of why do they think specific joints were failing. Some things in the joint selection that I didn't mention yet was that the installation and inspection practices basically would determine which joints they used sometimes and the regional contractor experience, because, for instance, the rural areas felt that their contractors, they didn't really trust them to do more complicated joints. So they would go with the simple a joint or the joint that they felt that the contractor had experience with, even if they felt it wasn't as good a joint in the long term. So we took that information, worked with MassDOT to come up with a survey to send out to other states. It had 5 different categories, went to 9 different states, which was New England, Pennsylvania, New York, and New Jersey. And if you're interested in the full response and some more detail on the comments that we got back, that's in the final report. Cut to the chase. What did we find out? Well, this probably won't be a surprise, but there was wide variability in the performance, in the preferences, and the service lives of any given joint. Okay? The definition of success and failure of a joint varied, and that somewhat surprised me until we started talking to people. And preventive maintenance and installation workmanship are very important, as everybody has pointed out. So success and failure, how does that vary? Well, definitions of success were, it should be watertight, it should require minimal maintenance, it should be long-lasting. Okay, that sounds great. Definitions of failure, it leaks, needs emergency repairs or has shorter service life than anticipated, or it doesn't provide a smooth riding surface. So from a survey response, that seemed pretty straightforward. But when we talked to them, we found that their perception of what is the anticipated service life, that has a lot to do with how you feel a joint has performed. The leaks, say there's a joint that you expect to last 15 years. There might be one person that is extremely happy with that joint because it lasted 10 years and then they started seeing a little bit of leaking through there and they knew that, yep, in 15 years, I've got 5 years to start putting it on my construction projects and get that fixed. And they were happy with that less performance at the end of the life of the joint. There would be somebody else that would say, it's supposed to last 15 years and at 10 years it was leaking. That's a failed joint and that's not what I'm expecting. So that led into trying to explain these results, where along the horizontal axis are just the different types of joints. Vertical axis is the rating, where 1 is an absolute failure, 5 is an absolute success. The darker bars are the average response from all the states. So from this, we can see that the link slab everybody rated it as almost an absolute success. Okay? This is the bounds, so the lighter bars are the bounds of individual responses. And everybody thought that that was quite good. For an open joint, well, just water pours through it, so yes, it should be an absolute failure as far as a joint. But then you come to something like a compression seal that had a fairly good rating, good to very good, but the individual responses were everything from very poor to an absolute success. And if you look at the individual responses, almost everything somebody thought was an absolute success, and almost everything somebody thought was an absolute failure or close to that. If you went just by the averages, you would take that data and say, these joints, the link slab, M-seal, compression seals, saw and seal, and finger joints perform pretty well, and the worst were the open joints, the sliding plate joints, and the pourable seals. Okay? But as I mentioned, there were high and low ratings for every type of joint. We then asked for the service life, the expected service life of joints. And across the top are the different types of joints, and then every 4-year increments that they could check a box to say what they thought the expected service life of that joint type was. And I want to just highlight a little bit of this, which is if you look at strip seals and compression seals, there is no consensus as to how long that joint should last. okay? Less than 4 years up to greater than 16 years. And when we would talk to some of these people, yeah, if it was less than 4 years, it was something where they said, yeah, I had an experience, we put that in, it was leaking 2 months later, it was awful. These are people that have been very happy with them. And then in between are the typical responses. Some of them, such as sliding plate and finger joints, were expected to last quite a long time. Some of them, such as pourable seals and asphalt plug joints, were expected to not last as long. If you look at the two, the asphalt plug joints and the pourable seals that had the shortest life, okay, the advantages of these are that they have quicker installation and repair. You can splice parts of them instead of having to replace the entire seal, and they're relatively inexpensive. So even though the central group in Massachusetts might be trying to get rid of some of these, the maintenance crews in the districts love these joints. Okay, this was what they felt they could maintain without having to go out to bid. They could just do it themselves for a lot of the joints. So they have an advantage even though they might not show up as being a great joint. Okay, or they're great at what they're intended to be, and that's the thing to keep in mind. We also had a question, and this bar is not necessarily so important what the numbers are, but we asked if you had routine repair and maintenance, which joints do you think would perform adequately? And this is just the number of people that checked it off. If they didn't have experience with that type of joint, they wouldn't check it. But essentially, every type of joint somebody checked, usually quite a few people checked that, yeah, if we maintained it, it would perform pretty well. And so they were trying to strike a balance of something that they didn't really have to do much maintenance because they didn't have the budget for that. So these are some of the ones that with good maintenance, asphalt plug joints, strip seals, compression seals, ones that might have shown up on the same person's survey. They might have said, oh, this is an absolute failure. But then they would rate it as fairly high if it had good maintenance, okay, or adequate maintenance. We also asked to rate the importance of different factors to the joint life. And the one that came across as everybody ranking really highly was the installation workmanship. Inspection, joint type, maintenance practices all ended up with people rating them, at least somebody rating everything really high. The weather conditions and the header type were other things that we asked about. So now I'd like to tell you a little bit about some comments that came through or recurring themes with the headers, which I'm not going into too much in this talk, but that was quite a bit of the survey was on headers. That if the old concrete needs to be taken out for replacement of a joint, it needs to be removed to sound material. And it came across again and again that where is sound material is difficult to assess, and usually it was left to the contractor to determine whether they got to sound concrete. Now that can be a very different number if it's a bid on volume or a bid on the project, okay? And it came up several times that 2 feet minimum on either side of the joint should be removed, but that always wasn't done, or wasn't always done. Applying headers to dry materials for the materials that are supposed to be applied to dry materials, or moist if it's supposed to be moist, is important, but wasn't always followed. And those that use the quick setting concrete or elastomeric headers, they typically would say that they didn't feel that they were as durable, but that they were what they needed, and that because they had the overnight construction or the shortened construction period. And in that, these are what they used. They're always looking for products that would be more durable, but they use many of the products that are out there. Some things that would negatively impact the joint performance is improper cleaning of the joint surfaces and substrate. And it was noted for those that were doing the quick construction that the sandblasting was often skipped, even though they knew it would deteriorate the joint more quickly. Okay. Incorrect opening sizes or placement of the seals, so maybe incorrect temperature, or the joint itself is the wrong size for the temperature that you're expecting to place the seal at. Bonding agent being applied at the wrong time, application of damp surfaces. If you have a joint type that requires bond breaker tape, which a couple recommend that it was often not put in, and therefore the silicone would just rip apart in the center rather than separating. That's usually on the saw and seal. And one state was mentioning that they thought that when they had phased construction projects that the joints performed more poorly than when they replaced the entire joint. For specific joint types, the saw and seal, it was mentioned how these are such small movement joints that people don't really think that they're that important from the contractor and inspection point of view, and you need to put the saw cut at the right location. So if you have the location that the saw cut is supposed to be above an existing joint and the overlay is on there, the contractor is going to guess where it should go, and it needs to be marked before the overlay is there, so they put the saw cut in the right location. If they don't, the deck will crack where the saw cut should have been. Asphalt plug joints perform generally not as well with high traffic volumes. Many of the manufacturers don't recommend them for that situation, and yet they were used in that situation, often with people saying, wow, they really don't hold up the way we want them to. Okay? And the backer rod was important in those. Compression seals, sometimes they are incorrectly sized and therefore don't stay in compression. Pourable seals, the surface needs to be completely clean and dry. And as I mentioned before, the location of that backer rod is actually important, and a lot of people didn't realize that it was important. And the anchorage of the armored headers was known to be a problem and caused some problems with sliding plate joints. So some new products that were mentioned, and you'll hear about these later. M-Seal was mentioned for that detail in particular on the parapets and curbs. Asphalt plug joints, many of those that were happier with their performance tended to use pre-bagged materials because they felt that otherwise there could be fluctuation in the performance of them if it was mixed on site. And several of the states and districts were combining them, almost a belt and suspenders, with using a strip seal or M-Seal with the asphalt plug joint on top. Other products that were mentioned were a Silica Flex or the inverted V, although called a V-Seal system, that they hadn't had a lot of, they were just implementing it, but very happy with them so far. And one state was using concrete troughs with finger joints behind the abutments, that they could use a concrete trough and just run all the moisture off of the bridge. And one state, I believe it was Maine, was looking at a lot of these armored headers, saying there were problems, but they thought it was just with the headers, the armoring being too small. They were looking at much heavier angles and anchorage and seemed to be very happy with the results on that. A couple of things that came up that I was maybe not surprised, but everybody talks about how important these are, and yet they're not necessarily done. The watertight testing of new joints. Only 3 of the 9 states surveyed did any water tightness testing, okay? So ponding water to see if the joint leaks after construction. Nobody did that on repairs, okay? Warranting joints is almost impossible, okay? Because what happens, I assume you're aware of, maybe it's different in other states, but in the Northeast, what happens is that if a joint is leaking shortly after construction, the contractor is going to say, well, there must have been something wrong with the joint. The manufacturer is going to say it was installed improperly, and then everybody's going to look at the DOT saying, well, it was you called out what joint to use, and you're the ones that were inspecting, you know, where's the blame lie? And so even though they felt that there were just blatant problems sometimes, and the manufacturer would come out and they'd talk it through and they knew what was wrong with it, they could rarely, if ever, get a contractor to come out and replace it. They had gotten into the routine of just bringing somebody out to repair it on a different contract. Yeah. Maintenance, extremely important, but only 5 of the 9 states actively did that, and even those that did said that it wasn't adequate, that it wasn't up to the standards they would like it to be, and this was invariably due to funding issues. And the key to this is that the investment in your joints is going to save all of the substructure and superstructure damage that follows. And I think that comes down to the funding. It's limited for the maintenance and preservation, and really need to think about it. This is my opinion, is that a major part of the problem is that we look at the maintenance budget, we look at the construction budget, and so forth, and when you have something that the maintenance group is then spending a lot more money on maintaining their joints, then people are saying, well, but our potholes are getting worse, and why aren't you spending money on that? So they don't get a lot of the benefit. And then later on, 10 years later, when there's less construction cost, they don't see any of that money coming back into their maintenance budget. Okay, it's not thought of as this overall DOT money pot and how one group helps the other. So some overall conclusions, or maybe recommendations that were come up with in the project. These joints are really important. I think everybody agrees on that. But if they're not addressed in a pre-construction meeting, talking about the joint installation and the expected performance, they're kind of thought of as an afterthought a lot of times. Okay? Training of contractors, installers, and site engineers related to the proper workmanship, the proper installation, the proper materials is really important. And almost all of the DOTs, and especially in the districts, they kept saying how they just didn't have time or the personnel to do that training properly. And manufacturer representatives are there to do a lot of this workshops and helping out with this, but are rarely used. They were rarely on site in any of the DOTs unless it was a new contractor installing a type of joint for the first time. Even if in the specs it called out that they should have been there or that they were supposed to be there. Watertight testing, I mentioned. I think even in a repair, you're not trying to assign blame of, oh, this is still leaking after the repair, but you'd like to know that it's still leaking so that you can stay out there and keep repairing it until it's fixed. Okay? And a lot of times it was just replacement contract, and then later on in the inspections, they'd say, oh yeah, there's leakage and continuing damage at this, without really checking the joint as it was installed. Preventive maintenance, extremely important, and I really don't think that can happen without tying these budgets together and really thinking about those life cycle costs. And then some, I guess maybe research, maybe things to think about as far as information to keep track of in databases. The evaluating the repair and replacement methods and contracting between states and between districts to see what are the best practices. It was very ad hoc in how people put together the contracts. Measuring the installation tolerances and actually seeing everybody says, oh, you know, it wasn't installed correctly, but nobody's actually got the data to show, or at least in our region, to show what are the tolerances that are not being met and what is the damage that results from tolerances that are not within the manufacturer recommendations. Header performance under different types of loads and coming up with test materials, test methods to approve those header materials is lacking in our region. And as I've mentioned, looking at those life cycle cost comparisons and impacts from the failed joint, so including what is the superstructure and substructure costs, not just the maintenance costs. So with that, there are several of the things. The full report is on here, so if you're looking for that later, the link is on the slides and my contact information. So, thank you.